Okay, so welcome back, and let's dive into Lab 9. We're talking about map scale this week, something that's crucially important for understanding maps, even at a very rudimentary level. Unfortunately, something that's often overlooked in understanding what a map is portraying and understanding its scale. And so you're in physical geography lab. You get to learn this. Get to play around with it. Cool. It should be a relatively shorter lab for you this week. So that's always nice on the heels of a midterm week to have a little rebound. And yeah, so here, let's talk about map scale. It can be thought of as the relationship between the measured distance on the map and the actual distance on the earth, right? On land or water. And there's three common ways to indicate the scale of a map. Graphic, such as in a scale bar. Verbal scale, which includes the units of measure. And then what's known as RF, or representative fraction, which doesn't have units. It's important to keep that in mind as we go forward here. And so yeah, the graphic scale, it's portrayed by a scale bar. Most of you have probably seen this somewhere on the map, usually in the key. Let's see here. On this map, this is a 1 to 33,120,000, or 1 inch equals 523 miles. And those would be under the verbal scale. And so yeah, National Geographic for that map has just stuck with verbal scale, not a graphic scale. So there's a little contrast for you. And yeah, what's important to keep in mind as well with the graphic scale is it may include several bars, each a different unit of measurement. Okay, so it's quite common to see the metric scale bar as well as the imperial system. For instance, kilometers and miles. And I don't think those are to scale right there. 200 miles would be, yeah, those are to scale. 200 miles would be 320 kilometers, so that's about 20 over. And that's probably an actual scale bar taken from a map. That's why it lines up so well like that. And yeah, we'll talk a little bit more later on about the variances that there can be with scale bars in terms of often, well, for instance, we get to see it right on this page. The 0 value may not be situated at the far left side of the scale bar. So for instance, here on the USGS cartographic map, we have a scale of 1 to 24,000. And this distance from the 0 here to here is 1 mile. And you might think at first, oh, the scale bar runs from here to here, and that says 1 mile. But you need to keep in mind that it's including almost what we would think of as negative numbers on a number line. Yeah, it's just a cartographic tool that is used to portray more of a scale line. It's often in this area to the left of the 0 that you can see smaller intervals of grading or shading, and those are often helpful. So likewise with the straight measurement in feet, we have our 0 right here, and to the left of that, here's another 1,000 feet, and we see 1, 2, 3, 4. So overall there's 5 different segments. So 200 feet intervals there. And then extending upwards to 7,000 feet on this side of the 0. And then exemplifying what we showed in the previous slide, here's kilometers as well. Again, with 1 kilometer indicated to the right of the 0 and another kilometer to the left. And as it says here, fractions of units are reserved for the left side. It's useful for measuring short distances on a map, those fractions of units, smaller intervals. We can mark the distance on the edge of a piece of paper and then determine the distance using the bar graph. That's a real handy little quick technique. It's just to hold up a little piece of paper right to that scale bar, and then you can mark off, with your fingers. Oh, and it's about 1 inch on the bar. It corresponds to how much. Alternatively, if you have some string, you want to measure out how long a trail is. You can just hold the string, even tracing the contours of the trail, the twists and turns, or a road, reaching an end length. Right? It's all windy, and then you take that, and then real conveniently you can hold it up against the scale bar and work your way over to determine how long of a distance you measured out on that trail or road. I feel like I'm halfway off your screen here. And perhaps I am. Sit more like this. Okay. Verbal scale. This is a map scale expressed as a fraction of or ratio that includes a unit of measure. So the numerator is the distance on the map. The numerator is always expressed as a 1. And the denominator is the actual distance on Earth. And so examples, 1 inch equals 2,000 feet. 1 inch on the map would be equivalent to 2,000 feet on land, or 1 centimeter to 4 kilometers. Likewise, 1 centimeter on the map would be equivalent to 4 kilometers on Earth. That one's pretty straightforward. It might be a little bit different to think of a numerator and a denominator in a numerical presentation that's just either side of a colon, but that's the language that is used. Sometimes it's expressed, very similar to how we would conceive of numerator and denominator in a math equation. One with a divided sign, or a slash, backslash, if that's it. I never remember which one's back, which one's forward slash. Doesn't matter for this case, we don't have one here, but let's take a look at representative fraction. This is a map scale expressed as a fraction or ratio that does not include units. The user applies the units, okay? So the numerator is the distance on the map, similar to the verbal scale. It's always expressed as 1, and then the denominator is the actual distance on the Earth. And so very similar to the verbal scale in this case, but without any units. Okay, so for example, 1 to 24,000, 1 to 400,000, and this is helpful for when you don't have to confuse yourself with inches, or with the imperial system or with the metric system. Just boom is what it is. 1 of anything could be 1 mile on the map if you had a really huge map, right? And would equal 24,000 miles on Earth. It'd be a really big map. Maybe we should go with feet, right, or something. A yard, 1 yard would equal 24,000 yards on Earth. I have seen maps that are at least 5 yards wide, about 5 meters. You can, some geography departments have these amazing wall maps, or floor maps, or what they're known as, and so those can be pretty neat for seeing really large scale maps. We'll get to large scale, small scale in a little bit. To continue on with representative fraction, then when converting a verbal scale to a representative fraction, we want to remember here that units of measure must be the same on both the numerator and the denominator. Okay, numerator always expressed as 1, and the representative fraction does not have units. Okay, because it's the same on both sides. Right? So in terms of verbal here, 1 inch is equivalent to 2,000 feet, or to convert that into inches, 1 inch equivalent to 24,000 inches. So a representative fraction would just be 1 to 24,000. I don't think you need to have RF in the parentheses after that. It's just for explaining that step in the bulleted list. Okay, so to determine distances on a map using the representative fraction, we want to use a ruler to measure the distance on a map in centimeters or inches. And this is what's known as the measured distance on the map. Right? Then we multiply the measured distance by the RF denominator, as the second number in the fraction. This will give you the actual distance in centimeters on the Earth's surface. Then we want to convert that actual distance, the denominator value, to appropriate units, or feet or miles rather than inches, or meters or kilometers rather than centimeters, right? Because when we have a 24,000 inches, that's just not too practical for conceiving of what type of space that is. So I'm going to convert, as the point says here, or it's essentially dividing, right? So as an example of that, cross multiply and then divide is the little title here. One simple method for calculating distances given a scale is to cross multiply and then divide. So you have a 1 to 24,000 representative fraction, right? And you measure out 14 centimeters on the map. Well, how far would that be in actual space, right? So we do some multiplication there, and that would actually be 336,000 centimeters. What the heck is that, right? Well, then we can, divide down. We can convert that into kilometers, something that's a lot more practically utilized, right? And, or if it was inches, we could take it to miles. But so that's about, well, it's not about, it's 3.36 kilometers. You think of each kilometer as about 0.6 of a mile. Yeah, you're coming up with about 2 miles there, if that helps you. If you're actually working with a map and you wanted to be like, I'm unfamiliar with how long an actual kilometer is on Earth. You do a little quick multiplication there and conceive of that. Visualize it a little bit easier for you. And I guess just on that note, when working with scale, it's useful to remember some of these conversions. 100 centimeters is a meter, 1,000 meters is a kilometer. Likewise, 100,000 centimeters then is a kilometer. And, 12 inches to a foot, 5,280 feet to a mile, and a whole bunch of inches to a mile. And, yeah, meter to a mile, 0.61 miles to a kilometer, sorry. So I might have misspoke on the no, yeah, I had my math right. Then on the previous one, 0.6 miles to 1 kilometer. So you multiply the 0.61 times your 3.36. Just referring back to this one, making sure I didn't lead you astray there. And then what this leads us to is, I mentioned earlier the notion of small or large scale. I mentioned those giant floor maps. Pieced together by a bunch of square meter smaller maps, or about a square yard, about the size of a desktop. Yeah, I think over, I don't know, there was 20, 30 of those we all pieced together, and it comprised this giant map of China, in this case, in the largest floor map that I've ever seen. In that case, that was a very large scale. And just to read you here, the terms large scale and small scale pertain to the relative comparison between two scales. There are no quote-unquote set scales that define large or small scale. Again, they are an expression when comparing two different scales. Okay, so for example, when comparing two scales, the larger denominator, the smaller the scale. And this is where it can get a little counterintuitive at first glance, but all are great college students, we can think this through a little bit. Or, conversely, the smaller the denominator, the larger the scale. When comparing two scales, as we say in parentheses here. So 1 to 10,000 or 1 to 24,000, which is considered the larger scale. And at first glance, you might think, oh, 24,000 is bigger than 10,000, so therefore that's the larger scale. But no, it's the inverse of that, right? It's 1 to 10,000 or 1 to 24,000. And so, one way to think of it is if you divide 1 by 10,000 or dividing 1 by 24,000, that second one, the larger denominator, is actually a much smaller amount, almost by 2.5 times smaller. Okay, so in this case, the larger scale is the literal larger number in terms of 1 divided by. 1 to 10,000 is a larger scale. And so if you had two maps of the same size, but to these two different scales, the same size piece of paper that is, the 1 to 10,000 would be showing you a smaller amount of land. Right? Larger scale equals more detail. And so yeah, the more detailed the map, right, in comparison to a less detailed map anyway, the larger the scale is. At first, and these are concepts that might not come at a drop of a dime, but I encourage you to think through it a little bit more, especially when you're going through the lab and taking an interest in maps that you see on a wall, or different maps that come up in your book, or maybe you find a map on a website. Start to clue into, well, what type of scale are they using? What is there a just to bounce back here for a little bit, what type of are they using a graphic scale? Are they using a verbal scale? Is there a representative fraction? Okay, so it's interesting to note what graphic a cartographer chooses to use, when the map was made. And so yeah, it's similar to previous weeks. I'd like you to read through the Lab 9 worksheet and then complete the 20 problems and answer them into the lab form and answer form, that is. And yeah, I should have put on here, of course, let me know if you have any questions, and I'd love to help out. Yeah, thanks for listening, and take care and stay safe, and look forward to hearing your questions. All right, bye-bye.